All right, here we go. Okay, excuse me. So we're going to do this one. So we're going to work with this one. Okay, so what's nice about this is, as you can see, a is 1 since the coefficient of x squared is not there, right? If it's not there, it's understood to be 1. -2, that's b, right? That's the coefficient of x. C is 3, as we can see. Okay. Okay, so we have that. So now that we have our A, B, and C, let's get the vertex. Notice since A is positive, right away we know the graph is going to open upward. To get the vertex, we have x equals -b over 2a, right? Which in this case is -2 over 2 times 1, which of course is just 1. So the vertex has x coordinate 1. Okay. The y coordinate, okay, to get that, we do f of this. So we get f of -b over 2 times a, right? Which in this case is f of 1, which is 1 squared minus 2 times 1 plus 3. So we get 1 minus 2 plus 3, which is just 2. So the vertex isn't that bad, actually. It's just the point 1, 2 in this case, right? Again, we got the x coordinate, and then we put it into the function, as you can see. Right. We also have the axis of symmetry. That's the vertical line through the which is f of 0. And again, since a is positive, right, we have this. So we know the graph has to look something like this. The vertex is, let me see if I can get this right, is at the very bottom of the graph, right? And again, since a is positive, the range is going to go from 2, the y coordinate of the vertex, all the way up to infinity. And this is what I was saying before. You, excuse me, you put a square bracket next to 2, right, the number, but you never put a square bracket next to infinity. It doesn't make sense to do that. Infinity is not a number, and neither is minus infinity. Okay? Okay, other questions about what I have so far? Okay. So for the x-intercepts, again, this one you probably could try factoring, but I was going to say, in this case, actually, you don't want to try factoring, excuse me, because it turns out there are no x-intercepts. Namely here, what happened was, if you use the quadratic formula, you get -b. Again, b is -2, a is 1, c is 3. So in this case, using the quadratic formula, right, we have -2 plus or minus the square root of -2 squared minus 4 times 1 times 3 over 2. You go through all this, but you can see, though, that we have the square root of -16 here. Okay? We have the square root of -16 here. And because of that, there are no x-intercepts, right? Because the square root of a negative is not a number, not a real number, that is. So altogether, this is what the graph looks like. Right? It never intersects the x-axis, as you can see. Okay, that's good. If you draw the axis of symmetry, it's going to look something like this. I don't know why I did not draw it. That was silly of me. but I'm drawing it now, somewhat. And again, the graph keeps on going up, forever, so to say. So, all right. Are there any questions on this? Okay. All right, so with the other class, I did this one with them. So why don't we do that? So for this one, okay. So for this one here, okay, we have A equals 1, B is minus 3, C is 2, right? As you can see, again, the leading coefficient, the coefficient's not written, so it's understood to be 1. So to get the vertex, as before, we calculate this first. Negative B over 2A. Okay, so from here, what do we get? We get negative 3 over 2, which is 3/2, okay? Which is, in fact, just 1.5. I mean, you could leave it as a fraction if you wanted to. Personally, I don't like to do that with this, but if you left it as a fraction, that's fine. I mean, with calculators and everything, you really don't have to. Keep in mind also, you have to plug it into the f of x, right? You have to plug 1.5 in for x, because we need the y coordinate of the vertex. And that's what I'm doing here. So we have f of 1.5, right? Which is, you just plug it in. You end up getting negative 0.25. Okay, so that's what we get here. That's good. Now we have our vertex, 1.5, negative 0.25. And we also have our axis of symmetry here, 1.5. Here's our y-intercept, f of 0 is 2. Okay. Right? Again, you just replace x by 0. It's just a constant term. The term with no x's. And just like before, we have our a is positive, right? We know that the graph looks something like this. I mean, it has to have this shape because a is positive. The vertex is going to be down here. Okay? And so the range then has to be from the y coordinate of the vertex up to infinity. So we have that. Okay. Okay, so let's keep, any questions on this? All right, let's keep going then. All right. So again, we want to get now the x-intercepts. This one actually looks pretty easy to factor, because we have 3 terms, degree 2. The leading coefficient is 1. Okay, so if we tried factoring, right, because we want to solve this equation, what do? We have 2 numbers we need, right, whose product is 2, whose sum is negative 3. Okay, what 2 numbers do that? Negative 2 and negative 1. So we get x minus 2 times x minus 1, okay? That's what we get here, right? Because again, the 2 numbers are, their product is 2, their sum is negative 3. So negative 2 and negative 1 are going to do that. So we have x minus 2 times x minus 1. And from here, we get this product, as you can see. Okay. So remember, how do you solve this equation? You set each factor equal to 0. We get x minus 2 equal to 0. And then you have x minus 1 equal to 0. You solve each equation. So for this one, you add 2 to both sides. You get x equals 2. Here we add 1 to each side, right? You get x equals 1. So 2 and 1 are the x-intercepts. From there, we know the graph intersects the x-axis at 2 and 1. So we get this graph. Again, I know I drew this using GeoGebra, computer software, that is. I think they have it in the school computers, actually. But again, if I were to ask you to draw this on an exam, I'm not going to compare it to this graph. I won't do that. As long as you get the vertex right, for instance, as long as you get correct what I ask you to find, that's all I care about. Because I cannot draw as good as a computer that can. So, again, this is the wonderful axis of symmetry. Okay. Good. Okay, so we have that graph. All right. Any questions on this? Okay. Okay, I was going to do one more example. I mean, there's more than one example in the notes, but I was going to do one more and then move on. I'll leave the examples, though, in the notes, so so you can always go through them yourself. It's just that this is taking me longer than I expected, but that happens. All right, let me just stop the recording.